We now learn how to solve inequalities in which the unknown x is being multiplied by a number as well as having a number added to or subtracted from it. And just as in the previous tutorials, we'll be using inverse operations to solve these inequalities. And the two examples are the ones that we see here, so let's go right ahead and get started. In this first example, we have to solve 2 minus 3x less than 8. To solve this inequality, we need to use inverse operations. But let me start by highlighting an important fact. As soon as we have something looking like 2 minus 3x, it's often useful to rewrite this as 2 plus negative 3 times x. And the reason for this is because writing it this way really highlights the fact that x is being multiplied by negative 3. Now that that's done, let's go ahead and solve this. On the left-hand side, we can see that x is being multiplied by negative 3 and that we're adding 2 to it. So the first thing I like to do is to get rid of any term without an x. In other words, I want to get rid of this 2 here. Since 2 is being added to the negative 3x, I need to subtract 2 from the left-hand side. So I write minus 2 here. And as always, whatever I do on the left-hand side, I must do on the right-hand side as well. So I need to subtract 2 from 8 as well. So on the left-hand side, we now have 2 plus negative 3x minus 2, which leaves us with negative 3x. And that's less than 8 minus 2, so that's 6. We now see that on the left-hand side, x is being multiplied by negative 3, and the inverse operation is therefore to divide by negative 3. But just as we said previously, if we're dividing the left-hand side by negative 3, we need to do the same on the right-hand side. And now we need to be careful. Remember that if we multiply or divide both sides of an inequality by a negative number, we need to reverse the inequality symbol. So this less than is going to turn into a greater than. Here's what I mean. On the left-hand side, we have x, which is being multiplied by negative 3 and divided by negative 3. Those two operations cancel each other out, leaving us with x. On the right-hand side, we have 6, which is being divided by negative 3. Now, 6 divided by negative 3 is equal to negative 2. But since we've just divided both sides by a negative number, we need to reverse this inequality symbol and state that x has to be greater than negative 2. And that's the final answer. And if needs be, we could illustrate this solution on the number line. So if 0 is here, negative 1 is here, negative 2, and so on. To illustrate x greater than negative 2, we would place an empty dot above the negative 2, as well as an arrow pointing towards all the numbers greater than negative 2. Notice that the dot above negative 2 is empty to highlight the fact that x cannot equal to negative 2. It must be greater. And that's our first example solved. Let's look at the next example. In this case, we need to solve 2x plus 5 less than or equal to 11. Well, once more, to solve this inequality, we're going to use inverse operations. Now, on the left-hand side, we can see that x is being multiplied by 2 and that we're adding 5 to that. The first thing I like to do is to get rid of any term without an x. So in this case, that would be the 5 on the left-hand side. Now, since the 5 is being added to the left-hand side, to get rid of it, we need to subtract 5 from the left-hand side. But as always, whatever we do on the left-hand side, we must also do on the right-hand side. So I need to subtract 5 from 11 as well. The left-hand side therefore becomes 2x plus 5 minus 5, which leaves us with 2x, and that's less than or equal to 11 minus 5, which equals to 6. Now on the left-hand side, I can see that x is being multiplied by 2, so the inverse operation is to divide by 2. And again, I have to do that on both sides of the inequality. On the left-hand side, x is now being multiplied by 2 and divided by 2, and since those two operations cancel out, we're left with x. Now we're dividing both sides of the inequality by a positive number, so we don't have to worry about reversing the inequality symbol. And we can just go right ahead and write less than or equal to. And that's less than or equal to 6 divided by 2, which equals to 3. And that's the final answer. Once more, we can illustrate that answer on the number line. So if I place 0 here, 1 here, and so on, To illustrate this solution, I place a dot above the 3, and I fill in the dot this time, as well as an arrow pointing towards all the numbers which are less than 3. Notice that this time I filled in the dot. That's to highlight the fact that x can be less than or equal to 3. And there we have it. That's it for this tutorial.